In this video, we're going to talk about how to interpret the slope of a least squares regression line. So we're using the same data set we've used throughout this chapter 8 here. We have for our x values, we have the size of a home in square feet, and then the selling price of a home in thousands of dollars. We calculated in the last video the equation of the least squares regression line. So we have y, or it should really be y hat for our predicted value, is equal to 0.099x plus 160.194. And I want to focus on interpreting the slope of the least squares regression line in this video. So if you think back to your equation of a line that you probably learned way back in algebra, you remember the equation y equals mx plus b, where m is going to be our slope. So the slope is always the number that sits in front of x. It's what we're multiplying x by. It's called the coefficient. So the slope in this problem is the 0.099x. So here is our slope. And I would like to talk about what this number means within the context of my real world data, meaning what does it mean in terms of the size of the home in square feet and the selling price in thousands of dollars. So when you first learned slope, you probably learned about slope as like rise over run is what I would expect. Most of us have probably heard that term at one point or another. And this helps you to graph functions. It tells you how much do you move up or down, and then how much do you move left or right. But I think for our purposes, I would rather think about slope as the change in y over the change in x. Because now I know exactly, well, what's my y variable? My y variable is the selling price in thousands of dollars, and then what's my x variable? My x variable is the size of the home in square feet. So it makes it, I think, a whole heck of a lot easier to interpret this because we already know here's what our y variable is, here's what our x variable is. So I'm going to take that slope that I found and I'm going to force it to be a fraction. So we have 0.099 divided by, I'm going to just say, okay, well, any number divided by itself is 1. So if you don't have a fraction, you can always kind of force it to be a fraction by putting it over 1. So this says here's the change in x, here's the change in y. So when it comes time to talk about this, I'm going to write a short little one-sentence summary describing what this number means. And when I start this interpretation, I am always going to start by talking about my change in x. That part's really, really important. So I'm going to start by talking about the change in x. So this says my change in x is 1. Well, what's x? My x is the size of my home in square feet. So in this case, if I wanted to talk about this, I would start my interpretation. I would say, well, if I was to increase the size of my home by 1 square foot. So I'm going to start by saying for a 1 square foot increase in home size. So I've talked about the x variable. Now I've got to talk about the y variable. So now I want to talk about how is this y changing. So what's going to happen to my selling price? Well, if I pause for a minute and think about how a number can change, it can either go up or it can go down. So I want to use a word that describes that change, whether it's increasing or decreasing. To make that determination, I'm simply going to look at the sign of that y variable. In this case, there's not one written. There's kind of a hidden plus sign right there. Since it's positive, it is a positive 0.99. So that means that my y variable is going to increase. So when I go to talk about this, for a 1 square foot increase in home size, we would expect the selling price, selling price to increase, and we're saying increase here because it's positive, by 0.099, in this case, $1,000. Now, you can scale your slope however you like. So in this case, you might say, well, 1 square foot feels like kind of a silly thing to say. Usually you measure it in, like tens or hundreds or something. So another way that we could say this is if, particularly if you end up with numbers that look kind of small for the units that you're working with, you can just say, well, I'm going to multiply both my numerator and my denominator by 10, just to make the numbers a little bit nicer to work with here. You can say, okay, well, if I multiply both my numerator and my denominator by 10, that would be 0.99 and 10 right here. So that would mean instead for a 10 square foot increase in home size, we would expect the selling price of the home to increase by roughly $0.99 thousand.